In FTC Robots Revealed, we get an up-and-close look at how all the different mechanical systems work on high-performing FTC robots.
We have 4 PTOs, 1 on each wheel.
And today we're going to take a look at Team 25650, One Small Step for an Axolotyl.
That allows us to adjust the compression.
And their robot that got them into the World Championships for the 2026 DECODE season. Now, some really unique things about this robot are some very impressive packaging for a lot of systems run in.
This is just an incredibly compact.
They have a double box tube slide to be able to lift their robot up. And they have one of the most clever systems that I've seen all season for being able to do indexing in a vertical manner.
The artifact comes out of here, hits into this back thing, scoops back down, and that's where these kind of little hugging arms.
Super cool. And you got to take a look.
Tell me a little bit about your robot. What's your overall strategy for this game?
Yeah, so overall, our goal is to be the best far shooter we can be, but also be compatible and be able to do every part of the game. So we have a counter-rollered shooter for great far accuracy, but we also have a sword and twin box tube lift for optimal compatibility with everyone.
Cool. So let's talk about your drivetrain then.
Yep.
Anything interesting going on there?
So we have a vision-guided intake, and we made custom 3D printed wheels for it.
So drivetrain-wise, we have 4 Swift drives. We have like a little gear attached to each of the Swift drives.
Yep.
That allows it to link with our PTO. We can talk about that in the lift a little bit more later. And then we have 3-wheel odometry. So we don't have I2C, pinpoint, octa-quad because ESD is pretty bad in Pennsylvania.
Yep. Yeah, this is just an incredibly compact bottom packaging for your robot. It is awesome to get so many features in there, which is really cool. Okay, so you've got 4 Swift drives. It goes onto your PTO then. We'll talk about that in a bit. What is this kind of gigantic triangle thing you've got going down?
Yeah, so can someone hold the bottom? So this triangle is our lift. We lift on like a corner part so that for most lifts, there's like a big plate. And the problem with that is another robot has to drive onto the plate, which can be hard with like the Mecanum wheels. Sometimes those can get stuck or just like slow them down. So we use a custom aluminum structure for like what we call our triangle par. And this only takes up like a centimeter of room. So we can leave like 17 inches or greater in the park zone.
Cool. And let's talk about your intake. How does your intake function?
So intake-wise, we have a row of gecko wheels with 3D printed rollers that funnel the balls in. We found that instead of a full row of Mecanum wheels, that takes a little bit too long. So we use these wedges to funnel the ball in, to help funnel the ball in. And with this, we can drive at any ball anywhere on the field at full speed, even not against the wall. And then for far, since we have such a large intake, it's really good at intaking from the far zone and cycling really fast. And we also have this 6mm thick aluminum blocker, so we can hit anyone with abandon and not care about damaging our intake. Early on in the season, we bent a lot of intake shafts. We broke a lot of Mecanum wheels. So this allows us to just gate cycle without any worries.
And let's talk about that transfer. How do you get from the intake over to your actual flywheel?
Yep. So we have a counter roller to help the ball suck in faster. We discovered that early in the season. It helps it be a little bit faster. We have like belt and a bunch of different sets of wheels for the transfer. And we have what we call hugs. These squeeze the ball, compress the ball against the lower surface so that we can have compression and send it up into the shooter. But when we're just intaking, we can spread them so that this surface speed is about the speed of the ball going in. So it effectively acts as a zero friction surface. So we can have balls go in as fast as possible.
And then on that transfer, it looks like you have some color sensors here as well as some sort of floodlight LEDs.
Yep.
That's to do color sorting?
Yep. So this tells us what balls we have in the robot. We needed the lighting so that we could have the color sensors a good distance back from the balls. Normally, that's a bad idea, but with ESD in Pennsylvania, putting the ball with a ton of charge too close to the sensor, that was pretty much suicidal in terms of ESD.
Okay. Yeah, 100%. Yeah, and you've clearly done a lot of stuff for ESD because you got like a thin 1mm polycarbonate all the way on the outside.
Yep.
Yeah. I love it. I love to see it. And let's talk about your shooter, because you got a lot of really interesting stuff going on there.
Yeah. So from the transfer, we have a movable back compression attached to a servo. So that allows us to adjust the compression and also kind of kick shoot like this to get it to push a ball into our shooter. Our shooter is on a greater than 360-degree turret with energy chain, which means that there's quite a substantial gap between the transfer and the shooter.
Oh, okay,
so we kind of need the little bit of pop to get accurately into the shooter. For the shooter itself, we have a double motor shooter with a main wheel and a counter roller, which gives us basically zero spin in the far zone, so we don't have tons of bounce outs.
And it looks like you made your own flywheel plates for this?
No, these are actually, I forget the company. They sell the wheels and the inserts.
Yeah.
I should know this, but
it's all good. All good. And then you have a dual motor shooter that actually gets it up.
Yep.
And this is, sorry, you glanced over so quickly.
Yeah.
This was like an actively powered
active
that
counter
comes
roller,
through on this here that is then on, it's driven just by a standard like O-ring belt. Is this?
Yeah, this is just round belt. We could have used like timing belts, but it's just simpler to go with basically a giant rubber band.
Yep.
Less finicky.
Yeah, it also stops you from over torquing it as well. So if you get too much. Yeah. Very cool. Can we spin the turret around so I can see the back of it?
We can go all the way from here. Then
Yeah.
we can rotate around to the back. We kind of just bundled the wires up so they don't hit anything. And on the other side, we have a little magnet for the magnetic limit switches on both sides. Of the,
okay.
robot.
So that's when you know you've reached your limit then.
We automatically re-zero the turret every time it rotates.
And on the inside of the turret itself, a lot of teams have been using Lazy Susans this season, but you guys have something different going on. What do you got going on?
So we have a custom bearing stack. We have thrust bearings, a normal bearing, and then another set of thrust bearings.
Yeah.
We experimented with some like Lazy Susans at the beginning of the season, but there are two main problems with those. Firstly, the sizing is restricted by whatever is available online, whereas with a custom bearing stack, we can make it whatever size we want. And then also custom bearing stacks are generally more resistant to like the impacts of like shooting and like not having like all the ball bearings pop out and go all over the field. So we thought it'd be a more robust system. I mean, teams have made both work, but this was just like very low effort. We just built it and it worked and we just stuck with it.
And you guys have one of the most unique sorting systems I've seen. Can you tell me how your sorting system works?
Yep, of course.
So we designed a magic Spindexer, and it works by having the turret pass the balls through into our intake and so that we can sort through. And as you can see here, you can see our sorting mechanism, and then you see it when the turret is facing towards the intake. But when you turn it around, it's just a speedy transfer and shooter.
So if it's ever facing on the inside here, can we turn that back around? Because I think it's clear from here, but I think it's much more interesting. We see here, we just lift this hood up really tight. The artifact comes out of here, hits into this back thing, scoops back down, and that's where these kind of little hugging arms can both come in and out to then allow that ball to cycle it through to do like a bit of a vertical Spindexer idea. Super slick. I love it. And then let's talk about your lift. How are you guys achieving your lift mechanism here?
Yeah, so we have two box tubes on the previously mentioned triangle on the bottom. To power that, we have 4 PTOs, one on each wheel. So on the bottom here, we have our Swift drive connected to this movable PTO that locks in on that gear. And then that has a gear reduction for the optimal RPM for our lifts. We got it down to 2.6 seconds. We have a little ratchet mechanism so that we don't fall down. And then since the PTO, the geometry of the gears was designed so it's self-locking. So once it starts locking, it doesn't disengage until we stop turning this wheel. And if you turn it the other way, it just skips. So our PTO only drives in one direction.
Okay, yeah.
And then a problem a lot of teams face this season with PTOs, their robots started driving away the second that they started using their PTO to lift. So our solution to that, we actually have, can you hold the bot? We have little servos here that push our lift down a little bit before we start lifting. And that's just enough to get our wheels off the ground so that we don't drive away and we have a very consistent spot.
Also, that just lifts you up. It's like a little rocker that gets you up.
Yeah, we use that for like a quick, what we call a pop-up lift to lift up in half the base zone in like half a second.
And then on your PTO,
Yep.
one thing that I think is not quite clear from the small aspect, we go back to that small prototype you had.
Yep.
Which shaft actually gets shared with your box tube for...
So the wheel turns, it spins these gears, and
Yep.
this shaft, this is our pulley. This is a outdated version. We made it slightly
okay.
bigger.
Yep.
But this goes directly to the box tube, which lays like right here.
So you're using like a rope to be able to drive the box
Yeah,
tube.
just Kevlar line.
It could theoretically be a belt ends up coming through here. So this is where, or, a string on linear slides from there, but you guys have popped that up over there. Super slick. I love that. Yeah. And I love this little passive ratcheting mechanism.
Yeah.
So that you don't fall on top of another robot, because that's certainly a problem that can happen with it. Okay. What are you guys most proud of about this robot?
I would say just integrating all of the aspects of this robot. I think we have a very unique sorting mechanism. We have box tubes with a bunch of PTOs. We have even a unique transfer, a counter roller intake, and then we're using Swift Drive, which not every team does. So it's been a challenge to put everything together, but it's definitely been really rewarding.
Oh, yeah. I think you guys should be really proud of your packaging for this. You've got a lot of mechanisms. It's a pretty big robot, but you've got a lot of things packed into here, which is really impressive.
Yep.
Well, thanks for taking your time to share that, guys.
Yep. Thank you.